On number 8, I use the half-angle identity in order to find tangent of 7 pi over 12. We have to use half-angle identity or sum and difference on this one. I suggest you practice both, but on the test you are going to have to use half-angle, so that's why I'm making this video, so that you can kind of be reminded how half-angle works. So we need to use half-angle because 7 pi over 12 is not a value that we have memorized on our unit circle. It's between values. Okay, so the first thing we need to do is apply the half-angle identity. And the way we apply it is to the angle itself. So our angle is 7 pi over 12. The way we write this is 2 times our angle, 7 pi over 12, divided by 2. We're really just multiplying by 1 there, which is what makes this legal. But that's going to allow us, multiplying the top and the bottom by 2, the angle on top is what we put into our equation for half angle. So when we put this into our equation, it's actually going to be a place on our unit circle that we know. When you do 2 times 7 pi over 12, remember that's 2 over 1 that you're multiplying by there. So that's 14 pi over 12, and 14 pi over 12 reduces to 7 pi over 6. So if you're looking at your equation sheet now, which you should be doing, this angle right here, 7 pi over 6, is your alpha or A. That's what you're going to be plugging in. So for cosine, for our half angle identity, for tangent, we do 1 minus cosine of your angle over 1 plus cosine of your angle. I'm going to go ahead and decide on the sign right now. For this, 7 pi over 12 is just a little bit more than pi over 2. And so that means that 7 pi over 12 is in quadrant 2. Tangent is negative in quadrant 2, so I'm going to put a negative out front. I'm just going to keep rewriting that negative. Okay, the next thing we need to do is replace cosine of 7 pi over 6 with the value of cosine of 7 pi over 6. At 7 pi over 6 on our unit circle, cosine is negative radical 3 over 2. So I'm just going to replace those. And from here on out, we have kind of an ugly and unpleasant, but very doable algebra 2-ish problem. We just have some radicals to deal with and some common denominators to find. So I changed my 1s to give us a common denominator. So I'm going to change my 1s to 2 over 2s. And then I'm going to combine my fractions over the common denominator. Also here I have minus minus, so those become positive. So I have 2 plus radical 3 over 2 in my numerator, 2 minus radical 3 over 2 in the denominator. And I have this big radical over everything and the negative out front. Okay, and for the next step, I'm going to write these out side by side. I don't have enough room here, so I'm going to do that on the next page. You go ahead and pause the video and do that as well. Okay, hopefully what you did matches what I have. Now we're going to flip the second and multiply. So we're going to flip the 2 minus radical 3 over 2. Okay, so it's all flipped. And now we can do a little bit of canceling. Here I have all multiplication. Remember, this is multiplied with 2 on top. This 2 is multiplied with this guy. And here I have 2 over 2 is 1. So I can cancel those. Your problem's going to get really, really messy if you try to distribute those 2's. So I have negative, big radical, 2 plus radical 3 over 2 minus radical 3. We don't want radicals in our denominator, So we are going to multiply by the reciprocal of the denominator. The reciprocal just is switching the sign in the middle. 2 plus radical 3. Whatever I do to the bottom of my fraction, I have to do to the top as well. Here's another place that your problem can get really, really messy if you're not careful. What we need to remember is that anything times itself, we can write as squared. 2 plus radical 3 squared. That's awfully nice since we're taking the square root. That's going to be our last step there, is to take the square root. Okay, in the denominator we are going to FOIL. Our middle terms are going to cancel because we did this plus minus situation. That's what the conjugate does for us. So 2 times 2 is 4. You can go ahead and think through the FOIL or double distribute, but your middle terms cancel. Radical 3 times radical 3 is 3. And it's a minus in between since we have negative times positive. So that gives us 2 plus radical 3 squared over 1. Whenever you're taking the radical of a fraction, whenever you're taking the square root of a fraction, you can take the square root of the top and the square root of the bottom. And both of these come out really nicely for us. 2 plus radical 3 squared, when we take the square root of that, it's just 2 plus radical 3. Square root of 1 is 1. And that negative is on the outside of the whole thing. So you can write it as negative parenthesis 2 plus radical 3 or negative 2 minus radical 3. Both of those are the correct final answer. Either one is beautiful.